Hey everyone, it's Ben from Board to Bits, and welcome to part 8 of our series on making modular textures in Unity. I apologize for cutting the last video a little bit short, but I quickly realized that the issue of handling layers of different sizes in our system was much more complex and involved than I had initially thought, so I wanted to make sure I spent the time and had the proper explanation on how we're going to make all of this work. So how our system works right now is currently we're setting the size of our final texture based on the very first layer we have, layer 0 in our array. From there, anything that is larger, it gets truncated basically. What happens is the array of color information we have gets truncated wherever the image ends. Now there's two issues with that. The first obviously being that we're not really controlling where we're cutting it off, but secondly, we're cutting it off as an array and not actually as a grid of pixels, so we're not retaining the proper rows and columns either, which can cause some a great deal of weirdness in the image when we suddenly see, kind of these broken up lines where we used to have something that was a shape. The second issue we have, obviously, is that anything smaller, an array that's smaller than our final image is going to throw an exception because it doesn't have enough information. We're going outside of the array trying to get that information, and it's just going to say nothing exists here, I can't do this, and just stop the system altogether. That's obviously the bigger problem because it completely breaks our program, but we want to solve both of these issues. And in doing so, we need to address A, the fact that layers may be different sizes, but B, the fact that each of these layers has a width and a height that we need to respect in order to maintain that layer's integrity. So, in order to do this, we have a few options of how we can approach this problem. The first one, and probably the simplest one, would be to simply say if any of the layers is a different size, we could just throw an error or an exception and say we can't work with different layer sizes and just, return a blank texture and just not do anything. Obviously, that's not our optimal solution. It might be if you always want a specific sized layer and all your layers should be the same size and you've done your due diligence about that, but chances are if you're trying, if we want some flexibility in the system, that's not our optimal solution. Another option would be to resize all of the layers in order to fit the base layer, which kind of opens up a whole new can of worms in terms of dealing with stretching and squashing images and how to deal with, kind of pushing pixels together and how you should do that, which isn't something we're going to get into in this video. That could be a whole series unto itself. So that's not going to be our ideal solution either. Also, chances are you don't necessarily want a squished image being layered on top of something. You probably want to retain that, whatever the aspect ratio is. Another option would be, instead of basing our texture size on layer 0, we could base it on the smallest sized layer that we have. We could go through each layer, check the sizes, and say, whatever the smallest is, that's going to be the size of our ultimate image. Again, I don't love this idea. I think chances are, if you have your base image and ultimately you probably want an image of a specific size, whether it's going to fit in a particular frame or it's supposed to fit to the screen in a certain way, things like that. You don't necessarily want it to suddenly change because you have a smaller image being layered on top of it, especially if you're adding in like little detail layers that might be really small, and so suddenly you thought you were going to get a 100 by 100 image and all of a sudden now it's 4 by 4 because you had a little added detail you were putting into it. That's not the goal of this, so that's not really going to work for us either. What I think the best solution I came up with for this is we're going to look at each layer and kind of recreate it in order to make sure that it fits properly in the ultimate final image. So how we're going to do that is, for each layer, we're going to look at that layer, we're going to create a brand new texture full of clear pixels that is perfectly sized to our ultimate destination texture. So if our final texture is going to be a 64 by 64 image, then this kind of placeholder texture we're creating is going to be 64 by 64. From there, if the width or the height is too large, we'll only take a chunk that we need from it that is the proper size, so in this case 64 pixels. Likewise, if it is too small, then we'll take that whole image, but we're going to make sure we place it right in the dead center of our new placeholder texture. So basically what this is going to guarantee us is that we get this new final layer, this kind of adjusted layer we'll call it, that is the right size, whether it has to be cropped or we've added in some filler around it, so that then when we are kind of blending our pixel arrays together, we know they're the right size, we know they have the right number of pixels in each row, we know that they have the right number of rows total, so we're not going to get any weirdness. It's going to be that right ratio, so that we can just combine these arrays without having to worry about, is it larger, is it smaller, is it, a different shape, so on and so forth. So in order to get, though, these chunks, in order to place chunks of pixels, right now what we've been using is get pixels and set pixels, and that's just taken entire images and dropped them into other textures. We need to get a little bit more fine-tuned with that, and we can do that by adding some parameters to those functions. In both cases, we're going to need 4 bits of information. We're going to need an int that is x and an int that is y, and those are going to kind of set the anchor point of like the starting point of our box of pixels we're going to take. And then we need to give it a width and a height. They call it the block width and block height. That will give us the size of that kind of rectangle of pixels we're grabbing or placing in. And that's going to give us basically the positioning that we want, either from taking pixels from our layer or adding them to the new texture we're creating. So we need to go about getting those, however, and that's kind of where the kind of a little bit of math and a little bit of logic has to come in. And I think it's best at this point if we dive into our script and start working on that. So let's jump over to MonoDevelop. So here in MonoDevelop, I'm going to do a little bit of housekeeping first. And the major thing I want to change here is this, what we're calling right now our array of colors derived from source textures, source array. I'm going to change this up a little bit. I'm going to rename this. I'm going to refactor and rename, and we're going to call this adjusted layers, because this is going to ultimately be where we place those either cropped or expanded layers based on the layers that we are importing in to the system. And I'm going to also just quickly change this a little bit here and say populate array with cropped or expanded layer arrays. So now we know what we're doing here is we are, instead of just taking the pixels wholesale and dumping them in, we're going to be, like I say, a little bit more careful about how we add in those pixels, or whether or not we need to add a border around them so we don't run out of pixels in our array and throw an error. Now, on our very first layer, we can actually just take that initial layer and use getPixels as we've been using it in the past, because we know that the base layer is the right size, because that's what we're basing the size off of. So we can actually add an if statement. If you go down here, I think I have to highlight this line. Yeah, and say surround with. And I'm going to say if, and so we're going to say if I equals 0, then we can actually just take the base layer that we have and plop it into our adjusted layers array, because it is the right size. We don't have to worry about that. Likewise, if we do know that another layer is the right size, if we've, like I've said, if we've been careful and we know, oh, this layer has the right width and height, we can just put it in as is. So I'm going to say here as well, if I equals 0 or layers I dot width equals new texture dot width and layers I dot height equals new texture dot height, then also we can just take that. However, it is worth noting, if only the width is right or the height is right, but its companion isn't the right size, we do still need to go through this process, because we're going to need to either add pixels to the sides or the top and bottom, or crop the sides or top and bottom. So make sure that you have the and here, and you're not just checking or. So in either of these cases, we can just take the layer as is and say you're fine, put you in, we'll save some time there. However, we are going to say else, if either the width or the height is different, then we need to go through this process of creating a clear layer, or clear texture rather, putting in the adjusted pixels, and then getting that array of pixels that is the proper size. So let's start here. The first thing we can do is create this clear texture that we've been talking about. So I'm going to say texture 2D. I'm going to call this sized layer. This is going to be the appropriately sized layer. Equals, and I'm going to call a function that doesn't exist yet, but we're going to call it clear texture, and we're going to pass in new texture.width and new texture.height, because we want to make sure it matches that width and height. Now, clear texture, we can't unfortunately just say new texture and give it those parameters, because if you just create a new texture, as we've seen before, it actually creates a texture full of gray pixels. They're a little bit translucent, and they're a light gray. And that we don't want that, because we don't want to be adding a layer of gray on top of everything. We want to make sure everything's clear so that if we wouldn't quote unquote have information there, we're not adding new information. We just want to add a completely blank pixel. So we do need to adjust this a little bit. So we're going to create a new function down here at the bottom. It's going to return a texture 2D. And I'm just going to call this clear texture. And it's going to take two ints, a width and a height. And so what we're going to say here is texture 2D clear texture equals new texture 2D width height. So this is currently our slightly transparent gray texture of the proper width and height, but not the right color. Now, while we can't just create a new texture and count on it to be blank, what we can do is create an array of colors and count on it to be blank. Anytime you create a new color and you don't give it any information, it gives you a red, green, blue, and alpha of 0, 0, 0, 0, which is exactly what we want, which is actually really convenient, because all we have to do is say color array, and I'm going to call this clear pixels equals a new color array of size width times height. There we go. And so that now gives us the array that is the right size and full of clear pixels. That's exactly what we want. So now all I have to do is say clear texture dot set pixels and set that to the clear pixels array that we just created. And now we can return clear texture because it's now been set to be a perfectly clear texture of the right size. So now let's jump back up to here. So now this is working. Now we've created this sized layer, and this is sort of the canvas where we can add in whatever new pixels we're going to add from the layers. So as I said before, we need 4 pieces of information in order to either get a chunk of pixels or set a chunk of pixels in a texture 2D. So we need the x, the y, and the width and the height. And we're going to need to get and set those. So we actually need 8 total pieces of information. I'm going to start with the x dimension, and then we can kind of easily translate that to the y dimension. You could separate this by the getting and the setting. I'm going to do it a little bit, not chronologically, but more, like I say, based on the dimension. So we'll start with the x's. So we need an x that we're going to get, the starting point from the layer that we're taking. We're going to need a width from that same layer, so a get x and a get width, as well as a set x and a set width. So I'm just kind of creating those 4 ints right now that I know I need. Setting each of these, we have to now look at, is the layer bigger, smaller, or equal to the texture that we want? Because like I say, there is a possibility that it's equal to. Chances are it's either smaller or larger, and that's really where things are going to change what we need to do with them. So for instance, get x. If our layer is smaller than the texture, or even if it's equal to, if it's smaller than or equal to, we can just start right at 0, because we're going to need that whole texture and put it into our new clear texture. So in those 2 cases, it can be 0. Otherwise, we need to make sure we're starting so that we're actually going to get the center chunk of the image. And so that we need to do a little bit of math for. So we could say this way. We could say if layers I is greater than new texture dot width, then instead of starting at 0, if it's bigger, we need to start inset in our layer, and the amount that we need to inset it is the difference between the layer and the texture. So layers I dot width minus new texture dot width. So that gives us the difference, and then we need to divide it by 2. We need to put this in brackets, or parentheses I should say. Divided by 2. So in this case, get x is equal to the width, the layer width minus the texture width divided by 2. And so that's going to create sort of that perfectly centering it once we add the width that we're going to take. Else, get x can just equal 0, because we're going to take the whole thing. We can start right at the start and go all the way to the end. This is about 5 lines of code here. We're going to do this 8 times total. This is going to get very long and very clunky very fast in our script. So I'm actually going to use what's called a conditional operator to condense all of this down to just 1 line. So we're going to do, instead of saying all of this if-else statement here, we're going to say get x equals, and now we're going to create this conditional operator. If you haven't worked with these before, basically what you do is you kind of ask a question. You say, is this condition true? And you put a question mark like you're asking it. If it's so, then you're going to have result 1. Otherwise, colon, result 2. Obviously, these aren't the variables we have. So the condition I'm going to ask here is the same exact thing here, is if layers is greater, if the layer size, that should be layers dot width. Same thing here. If this width is greater, the layer width is greater than the texture width. If that is the case, then result 1 is going to be this right here, the difference divided by 2. Otherwise, copy that, it can just be 0. And so this is doing the exact same thing as all of this. So we can delete that now. Get width. Similar idea. We're still going to ask again now if it's larger, if the layer is larger than the texture. If that's the case, then we want to use, if the layer is larger, we actually want to use the texture's width. So instead, we're going to say new texture dot width. Otherwise, if it's equal to or smaller, then we can totally use that layer's size, because we're, like I said, using that whole layer. Makes sense to use the layer size. So we'll say layers I dot width. Setting the x and the width is the same idea, but just kind of flipped in reverse, because at this point now we no longer really have to worry if the layer was larger, because we've cut it down. At this point here, we can, once we've gotten the proper chunk of the layer, we now know that it's not going to exceed the size of our texture. We've already cut it down. So what we do have to worry about now is if it's smaller, now we need to kind of take care about how we're positioning in the same way that we were positioning our cuts in the get section of the system. So here now we're going to say if layers I dot width is less than new texture dot width, now we need to center the layer in the new texture. So new texture dot width minus layers dot width, layers I dot width divided by 2, or it can be 0. So if it's equal to or greater than the size originally, now we can just plop it right in because it's going to fill up the whole thing. However, if it's smaller, now we need to inset it. Likewise for set width, layers I dot width is smaller than new texture dot width. If that's the case, then now if it's smaller, we want to use that layer size because we don't need it to be bigger than that. Then we would start getting that weird line funkiness going on. So here again we can say layers I.width, or if it is equal to or was originally greater than the size, we can just use the texture's width because we're going to be filling up that texture. New texture dot width. So the easiest way to kind of look at this is to see that we're switching the, for setting it, we're switching the greater than and less than, and we're actually just swapping the position of layers. New texture becomes new texture minus layers, and likewise here, we're using new texture, or now instead we're using layers. Here we're using layers, or instead we're using new texture. So it just kind of, it takes that same process and kind of flips it around. So now we're going to do all of this again for our vertical, for our y, and for our height. And really all we're going to have to do here is just change x to y in every situation and width to height. So I'm going to quickly speed through this section so you don't have to watch me painstakingly do this. Okay, so now we have the 8 pieces of information we need. We have the 4 bits to get the rectangle we're taking out of the layer, and we have the 4 ints that we need to place our layer into the new clear texture we've created. So now we just need to actually get those pixels and set those pixels appropriately. So to get the pixels, we're going to say color, and I'm actually just going to call this get pixels because these are the pixels that we're getting from the layer, equals layers I dot get pixels. And now, like I say, instead of using just the blank or just the empty parameters, we're actually going to put in, if you go down here, you see here, x, y, block width, block height. So we're going to say get x, get y, get width, and get height. And now we can set that into our sized layer that we created. Sized layer dot set pixels, set x, set y, set width, set height, and then we need to actually give it the array of pixels that it should be getting, which is the pixels that we just got. Lastly, we can say adjusted layers I equals sized layer dot get pixels, because we're ultimately, and that's just going to be the entire thing because we know it's sized correctly. But this adjusted layers array is the array of color arrays, so we can't just put in the texture we created, we actually have to get the pixels one more time. Now, this is a little bit inefficient here because if you think about it, if we know for a fact that both the width and the height were bigger than the original, or than the final texture we're creating, then we don't actually need to put it into the sized layer, because the sized layer is really more for taking a smaller image and making sure we have the blank pixels around it. If both sides were bigger, we know that once we cut it out, it's the right size. Basically just like we've cut the crusts off of it. So what we could say here at this point is if layers I.width is greater than new texture.width, actually sorry, greater than or equal to, and layers I.height is greater than or equal to new texture.height, then in this case we can actually just put in new get pixels. Adjusted layers I can equal get pixels, because these next two steps are really just putting in all the pixels and then taking them out again, which is 2 extra steps we don't need to do. So it's a little bit more efficient, but we do need to now say else if both of those aren't larger, then we need to make sure we're doing these steps. Technically speaking, we're only ever using sized layer right here, so we don't really need to create it until we actually need it. So I'm going to bring this down and into there as well, so that we're kind of saving that process of going through and adding all of those empty pixels unless we really need to. So there we have, finally, a more efficient way that is ready to handle layers of different sizes and can nicely handle if something's too wide but it's actually shorter, or if it's too tall but actually narrower. It will handle that as well. Like, it will know, oh, chop off the top and bottom but add pixels to the sides. It's a very flexible system for making sure that even if you have different sized layers, it's not going to break your texture making script. Let's see that in action here now. If I jump back over to Unity here, I've got a few sprites here I've made of different sizes. This one is a 32 by 32. This one is only 16 in width, but it's 64 in height, so it's taller. And this one is 64 in width, but 16 in height, so it's wider but shorter. So now let's go over to Sprite Maker. I'm going to add first the cube or the square, and then we'll layer on the magenta and the yellow. Bear in mind these are going to take on the color of our color array. But we'll see now if I hit play that we start with the square size, which is now being colored green here, and then it layers on that tall magenta, and then finally layers on the wide sprite. And both of those, we see that we are maintaining the clear pixels, but we are chopping off the extra on the sides. So that's working exactly the way we want it to. Thanks for watching. Next time I'll get into those final couple things about dealing with color arrays, and if there's like a different amount of color arrays you have, or if you don't have them at full opacity, and some cool stuff that you can do now that you have this information about how textures work. So thanks for watching, and I'll see you next time.